Here at DET CRC we have developed the RoXplorer. The RoXplorer coil tubing rig drills to 500 meters using a continuous malleable steel coil with no rod handling, thereby providing major cost and safety benefits. The downhole motors, hammers and bits are driven by fluid recycled using a solid removal unit, providing the major environmental benefits of no fluids being released to the ground surface. The RoXplorer weighs only 15 tons, including the drill string, and can be easily road transported. We have conducted 2 major field trials with the RoXplorer and systems. The Port Augusta trial demonstrated that typical adellation cover of the Gawler Creighton, including quartzites, can be drilled at rates approaching 100 meters per 12-hour shift. 367 meters were drilled in 4 consecutive shifts and an average rate around 15 meters per hour when drilling. Diamond drilling in the adjacent hole achieved 25 meters per shift and an average rate of 3 meters per hour when drilling. Assays of the cuttings from the Port Augusta trial show a remarkable match to the assays of diamond drill core from the adjacent hole, including across a 1 meter zone of low-grade copper mineralization at 400 meters depth. The Horsham trial demonstrated that unconsolidated cover of the Maury Basin and underlying basement could be drilled at similar rates to those achieved at Port Augusta. The hole was drilled through cover and cased to 140 meters depth in 3 12-hour shifts. 270 meters of basement were then drilled in another 3 12-hour shifts. Previously sonic drilled hole with a diamond tail near the Horsham hole was drilled to 180 meters at an average of 12 meters per shift. It is unlikely that the Horsham hole could have been drilled by reverse circulation. Thus, coil tubing provides the only cost-effective alternative to expensive diamond-tailed holes in mineralized basement covered by the Maury Basin. The RoXplorer coil tubing drilled holes were straight and vertical in both trials. Drilling rates in both trials were also consistent with achieving our target drilling cost at $50 per meter.
The point of drilling is to gain an understanding of the subsurface geology with accuracy and depth resolution that can drive decision making. Fundamental to this is collecting a sample of the drill cuttings that can be accurately located with respect to its depth, is representative of the downhole geology and is amenable to in-field and lab-based analytical techniques. Drilling in CT percussion mode, the RoXplorer produces approximately 7 kilos of sample per metre drilled. These cuttings are brought to the surface by the drilling fluid. Our challenge is to take a representative sample of those cuttings, remove the water, dry them and prepare them for analysis.
Our drilling fluid is used to power the downhole assembly of the drilling system. To do this, we require high-quality drilling fluid. The coil tube drilling system utilises a collar capture device. This system recovers the drilling fluid, sends it to the solids recovery unit where it passes through a series of processes, first being the shaker screens, then decanter centrifuges. We then have a series of flocculant dosing points, and then finally into a collection tank ready for reuse back in the borehole assembly. In a recent field trial, we managed to recirculate over 300,000 litres of drilling fluid with a total system volume of only 9,000 litres. We were able to consistently produce a solids loading of only 50 to 60 parts per million and a cut point of less than 10 microns. It's a critical requirement of the coil tube drilling system that all of the drilling fluid is reclaimed. This is not only an economic consideration, but it also minimises our environmental footprint.
In simple terms, we have got 2 systems to use in this operation. One is a C-Troll and the other one is a C-Troll X. C-Troll is a blend of polymers that is used while drilling. It's a fluid with certain viscosity, with certain rheological properties that provide us optimal drilling operation, help us increase the rate of penetration, help us to control the fluid loss into the formation. The C-Troll X has got a number of loss circulation, cellulose-based material that goes into the formation and basically block the formation and stop the loss.
We're third generation broadacre farmers. We used to have some sheep, but now we've moved into a pure cropping program. The Wimmera Plains is particularly flat, and when we were showing the magnetic imagery of the soil profile, it was interesting that it was so different underground. Farming's all getting towards big data, and so we're wanting to know more about what's happening with our soils, so we want to know what's underground as well. And I think that's one of the highlights of this program, is actually getting more information about what we essentially can't see, and then how we can use that later.
At the Port Augusta and Horsham drilling trials, we deployed a world's first sample splitting system designed and fabricated by DET CRC. The splitter intercepts the sample in the fluid circuit prior to the solids removal unit. The device delivers 2 equal mass sample streams. This allows one sample stream to be dedicated to primary sample collection, while the other stream can be used for collecting chip samples and periodic duplicates. The chip sampling provides an immediate visual record of the downhole geology, with particle sizes that allow identification of rock type, mineralogy and textural information at grain scale. Geological boundaries are sharply defined and closely match those in the adjacent diamond drill hole MSDP2. After dewatering and drying, we submitted the primary sample stream from MSDP15 for lab assay by the same techniques as we used for the adjacent diamond drill hole. The results show an excellent match between the coiled tube drilling and the diamond core assays. Geological boundaries are located with decimetre accuracy in the geochemical data from the coiled tube drilling, and concentrations of major and trace elements are comparable to the half-core assay results. An approximately 1 metre interval of elevated copper with visual sulphide in the drill chips was accurately resolved in the coiled tube drilling geochemistry from a depth of 400 metres. These results demonstrate that coiled tube drilling with appropriate sampling technology can produce a depth-accurate sample that is representative of the subsurface geology.
These trials have opened the Gawler Creighton, Moree Basin and other areas of cover to prospecting drilling, which will enable progressive vectoring towards concealed mineral deposits using multiple cheap holes in a single drilling campaign. We believe that the RoXplorer and related technologies has the potential to change mineral exploration fundamentally.